Skill 29, Angle Sum Theorems. As a bell ringer, let's answer a couple questions. First, recall how many degrees there are in a triangle. There are 180 degrees in a triangle, and we get that from the triangle angle sum theorem. Now, if a triangle has angle measures of 48, x plus 12, and 2x plus 21, we want to find all three angle measures. So if we have our triangle, we have 48 degrees, 2x plus 21, and x plus 12. Then what we're going to do is add them all together. 48 plus 2x plus 21 plus x plus 12, and set that equal to 180. And then we're going to solve that for x first, giving me 3x plus 81 equals 180. And then we're going to subtract the 81 over. So 3x equals 99. Then divide by 3, so x equals 33. Okay, now it says find all three angle measures, so that would be 48 degrees. And then x plus 12 would be 33 plus 12, which would be 45 degrees. And then the other one, 2x plus 21 would be 2 times 33 plus 21, which is 87 degrees. So those would be your three angle measures. Now what we're going to do in this skill is we're going to be finding the sum of interior and exterior angles of any kind of polygon. First, with a couple definitions. An equilateral polygon is a polygon with all sides that are congruent. So if all the sides are the same length, then it's an equilateral polygon. If it is an equiangular polygon, then all of the angles are congruent. So equiangular angles, equilateral would be the sides. A regular polygon is a polygon where it's equilateral and equiangular. So regular is if it's both, equiangular if it is just the angles, and equilateral if it is just the sides. Next, there's a couple of theorems to go over. So the first one is the Polygon angle sum theorem. That says that if we add up all of the measures of the interior angles of a n-gon, which means any type of polygon, then it's going to equal 180 times n minus 2. And a corollary to that, so a next theorem similar to that one, is the measure of each interior angle. So the measure of one interior angle of a regular n-gon is 180 times n minus 2, but then you divide that by n. So you do the same thing as we did before, just divide it by n. And then the Polygon exterior angle theorem says that the sum of the measures of the exterior or outside angles of one at every vertex is 360 degrees. So it doesn't matter what type of polygon it is, it's always going to be 360 degrees. Now for a couple of examples, we want to find the sum of all of the interior angles of a heptagon. First thing to note is that a heptagon is 7 sides. So when we're trying to find the sum, we will use the formula, the sum equals 180 times n minus 2. Well, n is going to be the number of sides. So the sum is going to equal 180 times 7 minus 2. 7 minus 2 is 5, so we're really just going to take 180 times 5. And that would give me 900 degrees is the sum of all of the interior angles of a heptagon. For this next one, we're going to find the sum of the interior angles of a 17gon. So that would be 17 sides, meaning the sum is equal to 180 times n minus 2, where n is 17. So 180 times 17 minus 2, or 180 times 15. 180 times 15 would then be 2,700 degrees for the sum of the interior angles of a 17gon. This next one we're looking at a little bit differently. The sum of the interior angles is 1,980. How many sides does it have? So we are looking for the n. So we know the sum equals 180 times n minus 2, and we know the sum is 1,980 equals 180 times n minus 2, and we are solving for n. We can do that a couple different ways. If we want to first distribute, we can do that. So then we would have 1,980 equals 180 n minus 360. Then we're going to add the 360 over, giving me 2,340 equals 180n. And then to finish solving for n, we're going to divide by the 180. And we get n equals 13 sides. So that would be how many sides this polygon would have. The common housefly has eyes that consist of 4,000 facets. Each facet is a regular hexagon, which means 6 sides. What is the measure of each interior angle of one hexagonal facet? So what we're really being asked is, what is the measure of each interior angle of a regular hexagon? That's really what's being asked here. So we're thinking the sum is equal to 180 times n minus 2, but then when we want each angle, then we're going to divide the sum by the number of sides. So that's really what we're going to do for each one. So for each angle, we're going to divide by n. So that means 180 times 6 minus 2 over 6. That's what the problem we're doing. So that comes out to be 180 times 4, which is 720, divided by 6, which will give us a 120 degree angle for each angle of a regular hexagon. Next one, what is the measure of each interior angle of a regular nonagon? Nonagon means 9 sides, so n is 9. So same concept for each angle. We're going to take 180 times the number of sides minus 2, all of that divided by the number of sides. So 180 times 9 minus 2 over 9. 180 times 9 minus 2 would be 1,260, which is 180 times 7, divided by 9. So when we divide that by 9, we would get 140 degrees for each angle of a regular nonagon. This next one, we're asking a slightly different question. We're asking for the measure of angle y. In this pentagon, 1, 2, 3, 4, 5 sides, 5 angles. So we're looking for y right here. We're going to add them all up and set them equal to the sum of the angles of a pentagon. So the sum of the angles of a pentagon would be 185 minus 2, and that's going to equal all the angles added together, which would be 110 plus the measure of angle y plus 150 plus 120 plus the little box means 90. Okay, so if we work out the left side, 180 times 5 minus 2, that would be 540 degrees in a regular, or in any pentagon. And then if I add all the numbers together on the right side, I get 470 plus y. So I'm solving for y because I want to find the angle y. So I'm going to subtract the 470 over. And y equals 540 minus 470, which is 70 degrees. Same idea on this next one. We're looking for the measure of angle G in the quadrilateral, 4 sides. So the sum is 180 times 4 minus 2 equal to adding all the angles together. So 120 plus 85 plus 53 plus G. And then I'm solving this. So on the left side, we have 180 times 4 minus 2, which is 360, equals 120 plus 85 plus 53, which is 258, plus the G. And we're solving for G, so we're going to subtract the 258 over. So G equals 102 degrees. For this next one, we're looking for the measure of an exterior angle. So that's one exterior angle of a regular octagon. Octagon meaning 8 sides. So if we want just one exterior angle, we're actually looking for this angle right here on the outside of the octagon. Okay, but if we use the theorem that says the exterior angles, sum of the exterior angles is 360 degrees. Well, then if we just divide the sum of the exterior angles by the number of sides, then we can get a single exterior angle. So that would mean I'm taking 360 divided by my number of sides, 8. And that will give me each exterior angle is 45 degrees of a regular octagon. And the next one, the measure of one exterior angle of a regular nonagon. Nonagon is 9 sides. So same concept as before. If we're looking for an exterior angle, we're looking for the outside angle right here. So that will be 360, which is the sum of all exterior angles, divided by the number of sides. So 360 divided by 9, which is 40 degrees for each exterior angle of a nonagon. So that's it for the notes on Skill 29, Polygon Angle Sum Theorems. So if you have any questions, make sure you let me know. Then do the worksheet and prepare for your quiz.